Okay, so let's get going on today's class. So today we're going to begin our final look at memory. We're going to delve into Chapter 7, which looks at the very important aspects of memory, encoding and retrieval. And we're moving away from ideas about the structure of memory, and now we're looking towards some of the processes that are at work within those structures. But before we get to that, just a real quick mention of the next social media professional development assignment, so assignment number 6. So for this one, what we're going to start to do now that we have interacted with our network, now that we've started to become a presence in the community, what we want to do now is we want to make sure that our account, our Twitter presence, has a consistent feel to it, has a consistent theme to it. Basically that you are about something so that the people that follow you will get a consistent sort of stream of content and it will be beneficial for them. So that's what we're going to be doing for this next one. So this is the idea of developing your brand. Basically, you want your Twitter account to have a unified theme. You want it to be about something, typically in general now for your professional account, it will be about psychology. But you really want to make sure that you're providing tailored content because those tend to be the accounts that have the greatest impact. So what we're going to do to help you along with that, you're going to, once again, tweet content that you find online. But this time we're going to look for 3 articles about an area of psychology that you yourself are passionate about. So something about psychology that you find interesting, that you like, maybe that you're planning on pursuing in either grad school or as a career, but some more specific area of psychology that you would like your account to basically be one of its themes. So for example, in my for my Twitter feed, it's mostly either educational or psychology of art type posts. So if I was doing this assignment, one thing I might post is a link to this article. The Smithsonian new study offers clues to the dominance of curve-filled museum design. So architects think that curves are more beautiful than non-experts, but they actually are less likely to enter a curved room. So interesting there. Harvard magazine published a very interesting article on the application of empiricism, experimental work to the arts and what that might do for the arts. And then a third article might be this one on why we like certain things. Basically, again, taking a look at the overview of art and basically taking a look at why people like certain types of art, certain abstract art, and what it means to have a science of art in general. So it can be on any area of psychology, but what we want is we want a nice unified theme. So if you're interested in developmental psychology, 3 articles about some area of developmental psychology. They don't have to be all in the same thing. If you're interested in clinical psychology, if you're interested in gender issues in psychology, whatever it is, try to find 3 articles within that area. And there's no restrictions on the date that they're from. So they don't necessarily have to be recent. You can see this one is back in July. So they don't have to be recent for this one, but this is more kind of just developing the theme of your account. So for this one, we're going to use the following hashtags. So you don't have to write anything about the article if you don't want to. Typically, I just give a sort of brief synopsis that would say something like, interesting article on the impact of, empiricism on art. But you don't have to do that, but definitely do use the following hashtags for your first article. IUSB MyPsych Area 01. For article number 2, IUSB MyPsych Area 02. And then article number 3, IUSB MyPsych Area 03. And this will be due the Monday that we come back from spring break. So Monday at midnight. By then, 3 tweets about 3 articles in an area of psychology that you are particularly interested in. Listen. All right. So what we're going to do now is we're going to continue our look at memory and hopefully be able to wrap it up today. maybe, maybe not. But what we're going to take a look at are some phenomenon in psychology to help us explain certain kind of big questions. One of these questions has to do with memory from our lives, and why is it that we tend not to remember anything below a certain age? So this is called infantile amnesia, and most of us do not remember our diapers being changed, even though this was a momentous occasion in our lives. Most of us do not remember, being picked up by our parents as a baby, even though this was a time of great joy. So what happened? Why do we not remember those? Why is there seem to be a limit to how early we can access memories from our episodic memories, things that actually happened to us? And then we're also going to take a look at a very, very interesting study that took a look at emotional memories. So memories that have very strong emotions tied to them from very traumatic events, and to see if they can actually, to put it in very general terms, erase those memories. So is it possible to actually erase memories or affect memories so that people with highly emotional memories can have an easier time or more productive time getting over and dealing with that traumatic experience? So that's what we're going to be taking a look at today. So we're going to start off with the idea of levels of processing. So this was a very revolutionary idea in memory, and you've experienced it in your CogLab, so we'll take up that as well. Then we're going to take a look at encoding specificity and what it means for infantile amnesia. And we will also take a look at how important memory is for development of the idea of the self. So we will kind of think again about Clive Waring and what it meant for him to lose many, many of his memories. And then we're going to take a look at memory reconstruction and take a look at science fiction as well as science fact. All right, so levels of processing theory. So this is a theory that came out as a sort of response to the structural memory theory. So we were taking a look at the structural memory theory approach up until now. So this is the idea that your memory can be divided into different structures, and the reason we remember things differently is because they get placed into those different structures. So will an item be recalled? Well, it all depends on which memory structure that item is in. So if it's in your short-term memory system, then you have less information that can be recalled, and it'll be retained for a shorter time. If it's in your long-term memory system, then will an item be recalled? Most likely yes, because you have an unlimited store, and you can recall information for a long time. But interestingly, whether or not an item will be recalled completely depends in the structural theory on which memory structure did it end up in. Did it make its way through your short-term working memory into your long-term memory? That determines will it be recalled. So that's the structure theory, and we saw a Broadbent's model of the structure theory. We went through the idea of short-term memory, working memory, and long-term memory. And it is one of the basic paradigms with which to study memory, and one of the basic ideas about how our memory works. However, there was another approach that came about to challenge this structural approach, and this is the idea of processing. So processing came up with the, or posited the idea that your memory and your memory ability is not due to different structures. It's not due to different mechanisms of memory, separate sort of entities in your mind. It's actually due to different levels of processing. So this processing is what affects your encoding and your retrieval. So how do you encode that information? How do you process that when you are learning what is to be remembered? And that directly impacts your retrieval. So for the processing theory of memory, when they're asked, will an item be recalled, they actually don't have memory structures to predict whether an item will be recalled. it depends on what the level of processing actually is. So it is a complete sort of inversion of the idea of memory, that memory, whether it's long or short, whether it's a large amount or a small amount, all has to do with how you process that information when you were learning or encoding that stimulus. So this is an overview of different stages of memory. So this is an overview of different structural views on memory. So this is the sensory registers. This is basically the imprints that a stimulus will make on your perceptual system. Short-term store and long-term store. And you can see that for the short-term store, it literally, once again, has that issue of being a bit of a circular definition, because a short-term store, what is it? Well, it's short, up to 30 seconds, and it's actually a small storage space as well. And that is what determines whether it's a short-term store. Whether it's a long-term store is whether you recall things from minutes to years. So if you are able to recall things for minutes or for years and there's no known limit, then that information was assumed to be in your long-term store. But the interesting thing about this is that there are other commonalities that are occurring, not just that this is small and short, hence short-term store, and this is no known limit in minutes to years, hence the long-term store, but there also seems to be other factors that are influencing this. So for example, short-term store. If you take a look at the maintenance of information, it tends to be, if you take a look at the maintenance of information and the format of information in these short-term stores, it tends to be information that was just rehearsed and information that is remembered in terms of verbal memory here, remembered in terms of the sound that it makes, right? So information that was just rehearsed and information that is remembered for the sound that it makes. On the other hand, long-term stores, typically information that's in your long-term store has been organized somehow. So you put some organization on it, and you don't remember just the sound of what this information was. You remember the meaning. Largely in your long-term store, you have semantically encoded information. So the idea was that maybe it's not the store, it's not the structure that is the important thing. It's actually how is this information maintained and how is the information encoded when you're learning it. Maybe what determines small and up to 30 seconds or no known limit and for minutes to years isn't a different structure. It's actually these different processes of maintenance and encoding. What's the format of information? So not structure, but some sort of different processing of that information. So this again came about partly because of the different systems had a bit of a circular definition. So how does short-term memory work? Well, it's short-term. How does long-term memory work? Well, it's long-term. So they were trying to get out of this definition. So instead of that, they once again said, let's look at the maintenance of information, how it's rehearsed, how it's encoded. Is it just rehearsal and sound encoding, very shallow encoding? Or is it being organized and is it semantic encoding? And that is what causes the different levels of memory. Yep.
I'm a little confused. Is this Broadbent's model or was Broadbent's model one of the structural understandings?
Broadbent is structural.
Okay.
Levels of processing is completely opposite of Broadbent's model. Mm-hmm. All right, so speaking of who did this, well, this was done by Craig and Lockhart, and they basically took a look at the structural model of memory and said to themselves, a bit of a circular definition, maybe there's something else. Let's go back to the idea, back to the basic assumptions. And they said, you know, maybe it's not actually structures that are causing any of this. Maybe it's the type of processing. Because the different structures, once again, information in those structures seemed to be tied to a very specific type of processing. So they proposed, well, maybe there's no structures at all. Maybe it all has to do with the type of processing. That's what's most important to memory. So they made a few assumptions to build their theory. Assumption number one, memory is the result of a series of processes. These series of processes are on a continuum, and that continuum goes from very shallow processing, which is a processing of just the perceptual features, all the way up to deep processing, which is the processing of things that have meaning. So, for example, if you were doing shallow processing of Craig's face over here, you might say to yourself, all right, I am just going to encode the perceptual features of this. You wouldn't even call it a face in that case. You would say of this blob of color over here. And there is this blob of white up here, followed by a blob of this darker pinkish color here. And then there are two lines of darkness right around there, with two circles of darkness right underneath. That's very shallow processing. That is processing the perceptual features without attaching any meaning to it, right? That's on one end of the continuum. On the other end of the continuum is where you process information so that it has meaning. So rather than this blob of whiteness up here, you say to yourself, oh, he has white hair. I'm attaching meaning to the perceptual features. I'm identifying it as hair. This is his skin tone. These blobs of darkness here, those are two eyebrows. Those two eyebrows are located above two eyes. So rather than just encoding the perceptual features, you encode the meaning as well, what that stimulus actually means, and that is deeper processing. And there's a continuum of types of processing, all the way from shallow perceptual features up to very, very deep meaning processing. So that's assumption number one. Assumption number two is that the levels of processing, where you are in that continuum, that determines your ability to retain information. That determines how much are you going to remember. So shallow processing leads to very poor retention. Deep processing leads to much better retention. So the idea here is that we do not have a short-term memory store. What we have is we have things and situations where we engage in shallow processing, and that leads to poor retention. And we don't have a separate long-term memory store. We have information that we deeply process, and that leads to better retention. So it's the levels of processing, not different mechanisms, levels of processing that determine how long and how much information you can retain. So note that, I saw some confused faces. Note that so far these are assumptions. They're building their theory. We'll see if it's actually the case in just a little bit. But once again, this is just their beginning, the concepts that they were trying to introduce. Assumption number three, this is a big one. Rehearsal doesn't actually help with memory. So the idea of repeating something over and over and over and over again does not actually help with remembering that particular item. It's only a byproduct of inducing deeper analysis. So if you're trying to remember somebody's phone number, for example, and you just keep repeating those words over and those numbers over and over and over again, it's not going to help you recall that information unless somehow it gives you some sort of deeper analysis of that phone number. So maybe you notice that your age is somewhere in that phone number. That's attaching meaning to a particular number. Maybe you notice that an important date is in that phone number. That attaches a meaning to that phone number. Maybe you realize that their area code is the Chicago area code. That attaches meaning to that phone number. Mm-hmm.
Would be like, is your mom's phone number attached meaning or no?
If somebody told you their phone number and you realized it was your mom's phone number?
No, like I've always remembered my mom's cell phone number,
Mm-hmm.
like more than anyone else. Like I don't even know my dad, but I know my mom. Like knowing that it's her phone number, does that give you like more, I don't know, like motivation to memorize it?
That might give you more motivation to memorize it. But in this, in their kind of model of information, you need to attach some sort of understanding to the information that's being presented.
Okay.
So I think whether or not it's your, that's your mom's phone number, that might have more to do with being cued for that information. So your mom and memories of your mom are probably a cue that helps you remember that phone number. And if those cues are stronger, as we're going to see later on, that will impact how well you are able to remember things. But the meaning that they're talking about is about the stimulus itself. Like you notice things about the numbers themselves. All right, so the effects of rehearsal, they're not direct, they're indirect because rehearsal helps you find that deeper analysis. All right, and assumption number 4, to study memory, you need to control the processing. So the last assumption that they had was that if memory has to do with how you process the information, then if you want to study memory and study memory effects, you have to control how people process that information. So because of that, much of the levels of processing theory was tested with what's known as implicit learning. And implicit learning is basically the idea that you are unaware that this material is going to be tested later on. So in a typical memory experiment, they give you a list of words and they tell you this is a memory experiment, try to remember these words. And you know for sure at some point later on in that session, you're going to be asked what were the words on that list. That's explicit learning. You are told to explicitly learn this material. In implicit learning, you're given a task to do, but you're not told that the information will need to be recalled later on. And then what they do is they basically give you a pop quiz at the end of the experiment and say, oh, remember that reading task that you did? How many words can you remember, from that paragraph? Remember that video that you watched? What color was the shirt of the person in the video? So it's an implicit learning. So one thing to keep in mind, implicit learning and explicit learning are different from implicit and explicit memory. So don't get those confused. Implicit learning is how do you encode it? Are you aware that it's a memory test? That's explicit learning. Are you not aware that it's a memory test? That's implicit learning. And then what they do is they make the task so that you are either forced to process the information in a shallow way, or you are forced to process the information in a deeper way. And we'll see that when we take a look at the CogLab. All right, so that was the levels of processing theory. Any questions on those 4 assumptions? All right, well, let's see if there's any evidence for this levels of processing. So we did a CogLab, levels of processing. Phase number 1, you saw a word and a judgment, and you were asked to make that judgment about that particular word. So your judgment, you were either asked uppercase, is the word written in uppercase letters? You were either asked the rhyme, does the word rhyme with another word? Or you were asked a semantic judgment. You had to answer a question about the meaning of the word. So these are the different ways to control processing. Uppercase, very shallow processing. Semantic, very deep processing. Rhyming, in between. And your task simply was to determine if the word fit the judgment. That was phase number 1. So in phase number 1, you would see this is the word in uppercase. So this is very shallow processing because in order to answer this question, you do not need to think about or encode or basically even know what this word means. So if I made up a word and I spelt it all in lowercase letters, you might have no idea what that word means, but you could definitely say that's lowercase. So this is perceptual features. This is very low, shallow processing. Does the word rhyme with park? In this case, you need a little bit more information. You need to start encoding information on whether or not the linguistic structure of this matches up with this. So you got to know something about what sounds do M and P make? You got to know something about what sounds do R and K make. That increases the amount of processing that you're doing for this particular word. And then finally, the semantic ones, is this word a part of the body? Here, you have to process the meaning of cart. You cannot, if this was in a foreign language, you couldn't do this task. You have to access what is a cart. You have to access what is a body. You have to understand, is cart part of body? So that requires a lot of processing of this word. That is the deep level of processing. All right, so that was phase 1. Then in phase 2, you saw a series of words. Half of them had been shown in phase 1. Half of them were not shown in phase 1. And your task was to simply indicate if you had previously seen the word or if it was a new word and it was not in phase 1. And the independent variable on this was the levels of processing. So shallow, medium, and deep levels of processing. So shallow, once again, was the uppercase judgment, where you didn't have to process anything but the perceptual features. Medium was the rhyme judgment, where you have to, at the very least, process the what sounds the letters make. And then deep processing was a semantic judgment, where you had to identify the meaning of the word. So that is much deeper processing. So once again, in phase 2, you'll be asked to, if the word was shown in phase 1. So was the word on the list? So we did not see this one before. Was this word on the list? Yes, it was. We would indicate yes for this one. So you had to indicate yes or no, were these words previously seen in phase 1. All right, so what are the results from the 3 conditions? So here we have proportion correct. So this is how many you correctly identified as being on the list. And down here we have encoding condition. So higher bars is better performance. And down here encoding condition, this is uppercase or shallow processing, rhyme or medium processing, and then this is semantic or deep processing. So let's start off with the uppercase or shallow processing. For that one, in that condition, subjects were at about 50%. So when you were encoding this information with shallow processing, your performance in this phase 2 memory task was about a chance. You could barely, I mean, you were 50-50, right? You had a 50-50 shot, and that's exactly what you did here. You had a 50-50 performance level. If levels of processing theory is correct, what we should see is that as the level of encoding goes higher, as the level of processing became deeper and deeper and deeper, your ability to recall that information should go higher and higher and higher. And what we find is that in the rhyme condition, you were much better at recalling the words in phase 2. And in the semantic condition, you were almost perfect in recalling the words from phase 1. So the deeper the processing, the better your memory retention was. So the deeper the processing, the more information you could retain, and the deeper the processing, the longer you could retain that information. So it could be, this is evidence that levels of processing is what determines, is it a short-term memory or is it a long-term memory? It might not be that we actually have these different structures. It might just be that we have these different types of processing. All right, so any questions about the results?
In the phase 1, were there any of the words that were repeated multiple times? Like maybe they were words subjected to different like phases in the encoding?
Do you mean like might you have seen the word boat and be asked, is it uppercase, and then later be asked, is it part of the body? Not to my knowledge. Did anybody feel that? It's been a while since I ran this CogLab?
I wondered that as well for multiple words, but maybe it was just the frequency from like phase 1 and phase 2, because I did notice a lot of words from the first phase being mixed in with like something completely different. It wasn't, I don't think it was just the testing, but like they did a lot of the words I saw repeat.
Yeah. Well, I mean, at the very least, the words from phase 1 had to repeat in phase 2.
Yeah.
You know, because of the memory condition. But if they did repeat the words, I don't think they would have, because that would have been a confound. Because if you processed boat in a shallow way and boat in a deep way, and then you were tested, we wouldn't know which one of these to put you in. So it might just be an artifact, kind of like a deja vu feeling that you experience rather than it actually being repeated.
When like on phase 2 and the word would show up, I could like recall like what they asked me about that word. Like not the uppercase, I could not remember those, or lowercase.
Yeah.
But if there would be like for rock, it was example, it was like, is this a type of mineral? So like when rock showed up, I was like, oh, that was a mineral question, and I pressed. Yeah.
There you go. So that's an indication of you actually did process that information more deeply, because at the very least you processed a lot more of that information. So it seems that it goes beyond, and well, that'll segue nicely into encoding specificity. It seems like it actually went beyond just encoding that one little piece of information like rock to encoding like the entire question. And notice that that was gone when you were for the uppercase one. You were not able to remember, oh yeah, this was the uppercase question one, indicating again that difference in your ability to retain those large pieces of information. All right, so let's take a look at a couple of questions here. So what kind of learning was occurring in phase 1? So let's assume, just for the sake of argument, that you had no idea that this was a memory experiment. Did anybody going in know that this was a memory experiment? Oh, okay, so some of you didn't. Okay, awesome. So what kind of learning was occurring in phase 1? When you were simply being asked, uppercase, what does it rhyme? You know, do these two rhyme? Or a semantic question about it. What kind of learning was that? What was that? It's actually implicit.
Oh, it is?
So that learning was implicit because you were not aware that you needed to memorize that information. So this is a good thing to make very, very clear. When you're talking about implicit or explicit learning, in psychology, it's got a very specific definition. It means whether or not you are aware that you are learning the material, or are you just interacting with the material. If you're aware that you're learning the material, that's explicit learning. It gets a little bit confusing because we got implicit and explicit memories as well. But in terms of, I wish they used the other words, but it's a very clear definition. Explicit learning is when you're aware that you're trying to remember the material, you're trying to learn the material. So when somebody says, memorize, memorize these lines. Any actor is doing explicit learning, where they're given a script and they go, memorize these lines, that's explicit. In phase 1, you were definitely learning because you were able to complete phase 2. But if you weren't aware that you needed to memorize those words, then that's an example of implicit learning. And typically in levels of processing studies, they do implicit learning to control for how people process that information. All right, and what kind of testing was occurring in phase 2? Was it explicit testing or was it implicit testing?
Explicit.
Phase 2 was explicit because in phase 2 you were directly asked, was this in phase 1? Access your memory and tell me whether it was in phase 1. You can also do implicit testing, and implicit testing is when you are not aware that you're supposed to use your information from phase 1, but it oftentimes will pop out. So for example, if you were given a word completion is oftentimes an implicit learning, an implicit testing technique. So if I said, finish that word, right? This word could be so many words. This could be caring, this could be cartography, this could be catastrophe, this could be other words. But if you saw the word cart in phase 1, you are more likely to complete that as cart. So you don't know it's a memory word. We're just saying, hey, complete these words. Whatever word pops into your mind. But what they find is that in a lot of these experiments, if you have seen cart before, you will, whether you're aware of it or not, complete this with the word cart. So that's an example of implicit testing where you're not told, use the words that you saw before. Try to remember them. You're just told, hey, finish this word, and it's a measure of whether or not you remembered that word before. All right, so according to levels of processing theory, what was the kind of processing that led to short-term memory?
Shallow.
It was the shallow processing. So again, according to levels of processing theory, we have short-term memory, but not because there's a part of our mind or a part of our brain that is a short-term memory structure. It's because we process information very shallowly. Long-term memory was due to deeper processing. So this has certain implications. So first and foremost, especially for everybody here as you continue to pursue your degree, this is one of the reasons why teachers will oftentimes tell their students, I don't want you memorizing this information. I want you to try to understand this information. So don't try to memorize it word for word. Try to understand the information. And what they're basically saying is, don't try to memorize the perceptual features. Don't try to just string the words along in some sort of perceptual shallow processing. Rather, think about the long-term meaning. Think about the not the long-term meaning. Think about the deep meaning of it. What does it mean? What does it actually entail? Pin it to other parts of your semantic understanding. So that's one implication from this. Another implication from this that is actually very optimistic and very hopeful for all of us is that the more you learn, the easier it is to actually learn more. So rather than having some sort of finite store in our long-term memory where we will fill it up, and then all of a sudden we're done. We're like, that's it. That's all I can remember. Levels of processing actually implies that the more you learn, the more you can learn, and actually the easier it is to learn. Because when you take a look at a word like boat, if you know tons about boats, then you have tons of semantic processing that can help you process that word boat. If you have very little idea of what a boat is, you just know it goes on the water, you just have one piece of semantic information that says, that'll help you process that. So the more you know about, for example, psychology, anything new that you learn, you can semantically tie it to so many more things. So as you go through your academic career, the things that you learn are going to get more and more challenging. But on the plus side, the stuff that you know that it'll allow you to understand that will actually allow you to remember it much, much better. There was a hand somewhere? Yep, cool. All right, so any final questions on levels of processing? All right, so we're going to switch gears now, and we're going to take a look at another phenomenon in psychology and try to answer the question of where did all these wonderful memories go? Why is it that typically people cannot remember anything below when they were 3 years old, right? So all that paradise of time between 0 and 3 is all gone. So why is that the case? Why do we have this infantile amnesia? So to try to address that, we're going to take a look at encoding specificity. And encoding specificity is the phenomenon that when we encode information, we don't encode it in isolation. We also encode the context within which we've encoded that information. And the example of from the previous CogLab, where when you encoded a word, you also encoded, oh, I remember, they asked about what is the meaning of that. They asked, is that a mineral? That's an example of encoding specificity. You encode the context along with the information. So if this is true, if it's true that you encode context along with information, then you should be able to use that context to help you retrieve that information. So if you encode context and information together, that means that they're going to be linked somewhere in your mind. So if you're given the context, you should then be able to be more likely to recall the information as well. So let's take a look at this is actually the case in the CogLab encoding specificity one. So in phase number 1, you saw a list of word pairs. And these pairs would be something like car and port there. And the first word and the second word differed. So the first word was lowercase letters. Second word was always uppercase letters. First word was the cue. And the second word was the target. So port in this case was what you needed to memorize. Car was just a cue that was given to you in order and presented in the same trial. So this is the information. You can think of this as the context. So there was 2 conditions. There was a strong cue condition and a weak cue condition. So something like this pair here, eat food, and dry wet, these would be both strong conditions. So eat is a strong cue for food because those 2 tend to go together. Dry is a strong cue for wet because those 2 tend to go together. Grasp is not a strong cue for baby. So that's a weaker cue. Babies do grasp, but I don't think it's the first thing you think of when you think of a baby. Lady, queen, I can't remember that would probably be a strong cue as well. But basically, if the cue was associated with the context, it's a strong cue. If they were unrelated, that would be a weak cue. So that was phase 1. You were learning the capital letters. You were given the lower letters as a cue. In phase 2, you were presented with either the strong cue or you were presented with a weak cue, and you were just asked to produce the target. So you were asked to produce the targets that you saw before, whether they were given with a strong cue or a weak cue. So independent variable number 1 was the encoding condition. Were you learning this information with a strong cue, or were you learning the information with a weak cue? Then, independent variable number 2 in the retrieval condition, were you given a strong cue to recall that target word, or were you given a weak cue to recall that target word? So the encoding times retrieval conditions, you encoded with a strong cue, and then you were given that strong cue in order to try to retrieve that information. You encoded with a strong cue, and then they gave you a weak cue. They gave you a different cue, but this one was weak in order to try to recall that target. You were given a weak cue, but then in the retrieval phase, you were given a strong cue. So now you get a better cue. Not the same one, but it's a better cue. And then lastly, you started with a weak cue, and then you were given that weak cue as well, trying to recall what that word was. So you were answering the question, was the uppercase word shown in phase 1? So this one was the uppercase word on the list. This would be an example of a strong cue being given to you in encoding, strong cue being given to you in retrieval. So we saw eat and food when you encoded it. That's a strong cue. You were given eat and then shown food, so you would say yes. So that was a strong cue for retrieval as well. Cave and wet. This is an indication, or this is an example of encoding with a strong cue and then retrieving with a weak cue. So wet is weakly associated with caves, definitely not as strongly as dry was. So you encoded this with dry wet, and then here in the retrieval you were given a weak cue. So you encoded strongly, but you were given a weak cue. Importantly, it's a different cue. Infant baby. In this case, the encoding was a weak cue because remember the encoding condition was grasp and baby. That's a weak cue. But now you're given a very strong cue to retrieve baby, right? Infant baby, that's a very strong connection. And then finally we have the weak cue and the weak retrieval. So they classified apparently lady and queen as a weak cue. So lady is a weak cue for queen. But in the retrieval condition, you are now given lady once again and asked if queen was the word that was on the list. All right, so we got those 4 cases. What did they find? What are the results? Well, let's take a look at proportion correct over here. So again, higher bars, better memory. Down here we have the encoding condition. Were you given a strong cue when you learned the pair, or were you given a weak cue when you tried to memorize that target? And then the blue bars are retrieval. If you received a strong cue when you tried to retrieve information, or did you receive a weak cue when you tried to retrieve information? Let's take a look. All right, so this is the test phase, phase 2. And what happened when you encoded with a strong cue, and then that strong cue was given to you in the testing phase? Well, not surprisingly, you did very well. You were very able to recall whether or not that uppercase word was present. So when you were given a strong cue in encoding and then that same strong cue in retrieval, you did very much better. What about when you were given a strong cue during the encoding phase, and then surprise, surprise, they swap it out for a weak cue? Well, no surprise there, you were worse, right? So it wasn't as good. You didn't learn with this information, and when you came to retrieve, it's not a very strong cue to help you remember that uppercase word. So that's encoding with a strong cue and retrieving with a weak cue. And you can see that when you're encoding with a strong cue, no big surprise, it's much better if you're retrieving with a strong cue. All right, so strong cue equals better memory. The question now to ask is, why does that strong cue lead to better memory? And it's quite possible that the strong cue just gives you a better memory, right? So even if you didn't do this test, and I just said, what's the first word that pops into your mind when I say infant? Many of you are going to say baby, right? It's a very strong cue. So maybe this memory has nothing to do with the fact that this matched your learning and your testing conditions. Maybe it has nothing to do with the fact that the cues matched in your learning and testing condition, and it's just that a strong cue is just better. It just leads to better memory. That's why this condition over here becomes so important. So this is when you learned with the weak cue, that useless word that wasn't very strongly associated with that uppercase word. You learned with the weak cue, and when you got tested with the weak cue, there's your performance. So you encode with the weak cue, and then you test with the weak cue. So if this memory is not due to the fact that you were able to encode the context, if this memory performance here was simply due to the fact that strong cues are just better cues, then we should see a very high bar here when you're given the strong cue at retrieval. What we see is we see a lower bar. So you are actually worse off with the strong cue if you encoded with the weak cue. So the key here is that in the weak cue condition, when you learned with the weak cue, your weak cue actually was better at helping you recall that uppercase letter. So what is the actual case is that a matching cue is the best for memory. It's the matching cues. If you learned with a strong cue is going to be good for memory. If you learned with a weak cue would be good for memory. And this indicates that it's actually you encoded the context when you were learning these words. It's not just that the cue itself is good, otherwise this bar would be higher. It's that you encoded the context. So even though grasp had nothing to do with baby, you encoded that word grasp with baby so that it could later be used as a cue to retrieve that information. All right, any questions about that? Mm-hmm.
This is like on topic, but I'm not sure if you're going to talk about it in a second or not. But could both the structure and level processing theories have like a bit of truth to them, and when it comes to understanding our memory as it functions in reality? Because like this sounds like the idea that there are levels of processing starting to make sense to me. Like that would make sense to describe human memory. But like if you get damage to your brain, there are different parts of you that you could lose if you damage that part of your brain. So there are obviously structures involved with memory. So are they both true or neither? Or
There's we actually weren't going to touch on that too much, but there's a ton of debate, and this happened usually in any area of psychology, especially when it was rapidly developing in the previous decades, where people would basically have a really burning interest in saying it's all structure. And then somebody else would be like, no, it's all processing. And you would go to conferences and there would be throwdowns and yelling and things like that. Same thing happened with perception, where people would be like, it's all top down, and other people would be like, it's all bottom up. And in perception, it looks like it is a mix of the two. I'm not as well versed in the memory literature, but it's interesting that you mentioned the damage to certain areas seems to get rid of your long-term memory, but your short-term memory is intact. So Clyde Waring, perfect example of that. Long-term memory gone, short-term memory intact. And the question, though, that levels of processing brings up is whether or not that has actually to do with structural areas that got destroyed, or were those areas important in the processing of information? Because one of the interesting things about Clyde is that he lost massive amounts of semantic information. So remember, he doesn't know who the queen is. He doesn't know who, he could barely identify other people. He couldn't form any new semantic memories. He learned 5 new pieces of information. So if you lose that ability to encode things semantically, then levels of processing would say, yeah, you're not going to remember them long term. Now, it would be very interesting, and it gets complicated because his memory impairments are tied up in terms of implicit versus explicit memory. So his explicit memory seems to be gone, but his implicit memory still has some things intact. And levels of processing is oftentimes an implicit learning type of structure. But it would be very interesting to know, out of his semantic memory that survived, was he able to learn anything else? But it really seems like a lot of his semantic memory is tied to procedural memory as well. So he knows music, but he can still do music. He knows language, but he can still do language. It would be an interesting question. But in terms of like answering that, I don't know where the current field of the research is, but it is a very interesting kind of non-intuitive version of memory that had a lot of success in terms of what is going to be retained long-term, what's going to be retained short-term, and importantly, had a lot of impact on educational system as well. So I cannot honestly remember the last thing that I had to memorize with rote memory. I can't remember the last time I had to like memorize a poem, right? Where understanding is not going to help you, right? So knowing that roses are red and knowing that blue is the color of violets, it's not going to help me rhyme, right, for that poem. And that's partly because of this levels of processing information, levels of processing theory. Because if you just have different structures, then one of the best ways to study for an exam, for example, is just read that material over and over and over again. Read it 5 times, and if it's not in your long-term memory yet, read it a 6th time, read it a 7th time. That's how you get it in there. Levels of processing said, no, don't read it. Go through it and try to understand it. Maybe make some notes, expand on it, link it to other things, in the real world. Try to put that semantic coding in there, and then that's what's going to help you remember things. All right, so that was the encoding specificity. So what learning instructions were given in phase 1? Was it explicit or implicit? Mm-hmm. It was explicit. So this one was actually a memory test. You were actually told, try to remember those uppercase letters. You weren't told to try to remember the lowercase letters, and they were never tested. They were just used as a cue. But this would be an example of explicit instructions and explicit learning. You were trying to learn what that information was. And the testing instructions given in phase 2, was that explicit or implicit? Those were explicit. Because once again, you were asked, do you remember the information from phase 1? An implicit version of that test would have been if they said, as quickly as you can, what's the first word that pops into your mind when I say baby? Well, no, baby was one of them. When I say infant, right, and you're like, oh, baby, that would be an implicit memory test because you're more likely to use the words that you remember, even though you're not being told to do a memory test. In this one, though, they asked you, were these on the previous list? So it's an explicit memory test. Now, that does not mean that you didn't, and this is where I really wish they used different terms. That doesn't mean that you didn't use implicit memory to help you with that test. That didn't mean that you were able to identify, oh yeah, lady was the one. You might have encoded it you did definitely encode the context. That might not have been conscious to you, so that would be an implicit memory, but the testing was definitely explicit testing. So that's a good thing to remember too, that just because your testing instructions are explicit does not mean that that is the only memory that's being involved, right? So if I tell you, try to remember how to play this piece on the piano, you're not going to not use your procedural memory, right? You're not going to avoid using your implicit ability to play the piano in order to do that task, even though I explicitly told you, try to remember how to play this. So be very careful with that. Instructions can be explicit or implicit. Learning instructions, testing instructions can be explicit or implicit, but that does not necessarily mean that it's only accessing explicit and implicit memories. All right, and we alluded to this before. Why do I project a clock on the front screen during the exams? And I believe we touched on this. It was because of encoding specificity. So this bright light here is a very weak cue, right? If anybody stopped you on the street and said, what's the first thing you think of when I say bright light? You're not going to say psychology, right? You're not going to say that. So this bright light here is a very weak cue, but it doesn't matter because it's a matching cue, right? So you do exams in this room with this board being lit up with something up here. So even though it's a weak cue, it actually does lead to better memory. And that's one of the reasons why I always feel bad for students that take exams in rooms other than the room that they learned it in. So when I was in undergrad, because of the size of our classes, we used to have our exams in like the gymnasiums, right? We used to be set up at tables outside of our classroom. And when I learned about encoding specificity, I was a little bit like, hey, I could have used the walls and the clock and the projectors and all that I had in my classroom to help me out. But again, that's why I have this up here, so that you do at least have this, albeit weak cue, just to help you out trying to remember those things. So use that on your next exam as well. Because if you're sitting there going, oh my gosh, I can't remember, question 16, what is the answer? Take a look at the board for a second, or the screen, and be like, okay, oh, all right, that's what it was. And it might help you. It might not. It's a weak cue, but it might. All right, we're going to wrap up today. We're not going to have time to get to the traumatic memories. We'll do that after spring break. But we will have time to do infantile amnesia. Wrap this all up. Take a look at what encoding specificity has to say about infantile amnesia. All right, so most people, they cannot remember anything that happened to them before the ages of 3 to 4. That is typically when the earliest memories that you can have. And interestingly, if you ask people about their memories, so I'll pop this up here. So this is a graph where they simply ask people in a bunch of different studies, write down everything that you can remember about your life and when it occurred. And what they found was that you are very, very good at remembering things. So this is age of the subject at the time of the event. So this old side over here, these are things that just happened to you. These are things that happened when you were old. This side over here, these are things that happened when you were young. Right? So what they found is that people are very, very good at remembering, we'll just focus on the top one here. They're very good at remembering things that just happened, right? So if I asked you to remember everything that happened in your life, you would clearly be able to say, well, I was in psychology, cognitive psychology this morning. I remember I walked here. I remember it was cold. I had cereal for breakfast. My roommate drank all my coffee. You'll remember a ton of things that happened very recently. Once you get out of very recent, though, it starts to take a dip. So this is something like, do you remember anything that happened to you 3 months ago? Very little from like that time period, right? Very little from like a year ago. That's why I always find it weird when you see those police procedural shows and they're like, where were you on the night of, January 16th? And I'm like, I think to myself, I have no idea where I was on January 16th because you don't have memory for, you don't have access for the, you don't have as many memories readily available from that time. But then as you get earlier and earlier and earlier, you go through this little hump of memory. So we have a lot of, probably for your ages, childhood memories, right? So you could probably remember a lot of things that happened to you during your childhood. You start to remember, this is when I got my driver's license. This is when I entered high school. This was my first kiss. This is when I fell down and scraped my knee. This is when I, went on the big slide for the first time. You get that little hump of memory. But then right about here at 3 years, all of a sudden, it's just like, no, that's it. That's as far as you can go back. So the question is where did this go? Where did all these memories go? Why is this kind of the limit for your ability to recall memories? So one possibility has to do with encoding specificity. And it has to do with the fact that your world when you were a baby is completely different than your world when you're an adult. And what that means is that the context that you used to encode all of these memories when you were a baby is much different than the context that you have to retrieve it as an adult. So if you are looking at a baby's face as an adult, this is what you see as an adult. When you were looking at another baby's face when you were a baby, that's basically what you see. Babies have, infants, when they're born, they don't have 20/20 vision. They got like 420 vision. Their vision is horrible. That's why any new parent, when they go to their baby to get that reaction, they go right up to that face and they're like, oh my gosh, you're the most precious thing ever. They don't do this, right? They're like, here, take a look at me, because this was your experience when you were a baby. This is your experience now. Notice, context, not the same. Weak retrieval cue. When you're walking around the room, this is the world you live in right now. That's the world you lived in when you were a baby, right? So it looks very, very different. Get on the floor and crawl around once in a while and think about when was the last time you ever did that. The world was very different. Context was very different. This is a weak retrieval cue. When you went to a party, this is the world, this is the context that you live in now. That was your context when you were a baby, right? Once again, much, much different context. So the idea here, in terms of encoding specificity, is one of the reasons why we might not remember this period of time is because all of that context that we encoded to, that could act as cues for our memories, all that context is gone. All that context is not being duplicated. So what we have is very weak cues for our memories that had strong cues when they were encoded. So we got weak cues for encoding. And interestingly, the implication for this is that if we could somehow duplicate this for this individual here, we might actually be able to retrieve more and more memories. So one of the, so if you could give a person this context, they might be able to retrieve more memories. One of the things that this also implies is that if you are able to make a theme park that was giant, right? Just a giant theme park where an adult could have this experience, that might act as a retrieval cue. And all of a sudden, this individual would be like, oh my gosh, I remember when I was 2 and I was in the bathtub and my sister hit me in the face with her rubber ducky. I remember it now. Mm-hmm.
It's so funny you say that because when I was 9, we went to Disney World, and at that time they had like the Honey I Shrunk the Kids theme park.
Oh, okay.
And so when you went, everything was like super huge, big, whatever. And so at that time, I just remember it being completely different than like real life, obviously. And I don't remember what I thought when I was 9, but it just makes me think like when I was 9, did I then start to remember like, oh yeah, I totally remember only seeing my mom's feet or whatever.
Yeah.
My pants looked like this big.
Well, that's what encoding specificity would predict. I mean, that is the definite conclusion from encoding specificity. There is, as always in psychology, there are other factors that are contributing to infantile amnesia, but this is definitely one of the possibilities, is that we just live in a world where the cues are completely different. So if they ever discovered a new island, and we went there, and it was filled with 16-foot people, we might walk onto that island, and after we were done freaking out, we might say, oh my goodness, when I was 3, I fell off my training bike, and I remember I scraped my knee, and my dad picked me up, and he started singing that song. Where was that memory? Well, that memory was encoded with that retrieval cue. So if you were able to reproduce that retrieval cue, then you could remember things you might be able to remember things when you're an adult.
So I was born in Pennsylvania, but I moved here when I was 2, so sometimes I forget I was born in Pennsylvania. But I've never been back there since. So do you think if I went back there, I might remember something?
Yes.
Because I've never been back. People talk about, and sometimes I forget. They're like, "Where are you born?" I'm like, "Oh shoot, I was born in Pennsylvania."
I mean, anecdotally, there's a lot of examples of those. So people, when they go back to their childhood home, all of a sudden they're like, oh, I totally forgot about this thing, or oh, I remember this thing. And interestingly, for memory, it seems that, and this might be due to your development of your perceptual system, the infant's visual system develops massively after they're born, right? So again, you're 2400 when you're born. You're 2020. I would think maybe at around 3. I don't know. That would be one of the predictions from encoding specificity. Other areas of your perceptual system that develop faster. And does anybody know the one sense that has the ability to retrieve memories the furthest back?
Smell.
It's smell. And that's why when people visit their childhood home and their mom is baking cookies or their grandma's baking cookies, and they're like, oh my gosh, I remember this. So smell can take you back the furthest. And it might be because smell would be way more developed early on, so that those cues, that encoded cues, are the same as you have when you're an adult. So when you smell it as an adult, it's not different than the context you encoded when you're a child. Visually, though, massively different than when you're a child. I remember, just to show you how sensitive and how much your visual system develops. When I was doing my PhD, we were doing things with 3D vision, right? So we would have 2D pictures, and you would have to fuse them, and in order to get the 3D perception. And those are the ones where, you remember they had those glasses that you can put on, or things that you can move backwards and forwards. But my supervisor could free fuse anything. You could just give him 2 pictures, and he would hold them up and be like, oh yeah, I get the 3D. Even with the glasses, I couldn't do it. I still couldn't do that. I just didn't have that ability. And when I told him this, he asked me, he goes, were you an early walker? And I was like, yeah, I started walking at the age of 9 months. And he goes, you didn't have time crawling around to develop your stereoscopic vision. And I was like, what does that have anything to do with it? It's a very sensitive, developmental scheme. But just to kind of, yep.
Now, to be able to see the 3D effect, did you have to do anything, or could you just look at it?
You have to cross your eyes. You basically had to focus in on. So the way that it worked is that the two pictures, you need to match them up on your retina so that they you could fuse them and then you would get the 3D. And the way to match them on your retina was for your eyes to move either closer or further away so that it got projected on different parts of your retina until it finally popped out. So all those magic posters that were flying around about, a decade or two ago, I never saw the whale. I never saw the starship. That was outside of my experience. Yep. But anyways, just to kind of wrap this up, we have this context, right? So this is what a lot of our parents used to do. I can't remember the last time I got lifted up that high, but I do know that this was done. But again, in terms of encoding specificity, this memory also encodes this context. So whatever this child is seeing is being encoded and can be used as a cue. So if this ever happens to you as a grown adult, don't be surprised if all of a sudden you're like, oh man, I remember that time at the beach, right? When you're getting carried off by She-Hulk. You remember that time at the beach. All right, so that's all the time we got for today. We are going to continue on with infantile amnesia because it's also very interesting how much of our memory is tied to ourself. And you will notice that something very special occurs in terms of a child's understanding of who they are right around that age of 3 years old when it seems to be the time that your memories start forming, kind of gets finalized. So we'll see that next time. Enjoy your spring break, and I'll see you all when you come back.